right, so measure the position. The last thing, 2, 5. Okay? Quartiles. 25, 50%, 75%, and then you have 100% too, of course, and 0%. All right, so in your calculator with your 5-number summary, we've already done the 411. Remember your information. You find the mean, you find the standard deviation, you scroll all the way down, you see the n. N is the number of pieces of data, and then you have your min, your Q1, your median, your Q3, and your max, right? That's what the 5-number summary is. IQR, interquartile range, is Q3 minus Q1. Remember, your range is the highest minus the lowest. So now an interquartile range is Q3 minus Q1. Box plot, also known as a box and whisker plot, you use the 5-number summary to create. Okay, and like I said, the 5-number summary is your min, Q1, median, Q3, and max. All right, so what I want you to do is I want you to put the following data in your calculator and 411 it and find the 5-number summary. Right? So you're doing your 5-number summary. So that's the mode you're thinking of. Put a dot at each of your 5 numbers, 12, 14, 15.5, 17, and 18. Okay? That's it. So then with the whiskers, you connect the first 2 and the last 2. Okay? And then from the other dots, you're going to go a 1/2 inch above and a 1/2 inch below. So a 1/2 inch above, 1/2 inch below. 1/2 inch above, 1/2 below, 1/2 above, 1/2 below. Like I said, on a test, you're only going to have to construct one of these, so it's got to be nice. Everything spaced out. Use a ruler, of course. When you do your graphs. Okay? And then once you have that, go across the top, go across the bottom. And that's it. There's your box whisker plot. Have you done those before? Way back when, right? 6th grade, yeah. This is who? Oh. Yeah. Okay. Now, along this line goes with percentiles, okay, because it's 100% of the data right here. So what they're asking here in exercise 2 is, what does it mean if you score the 73rd percentile for the verbal section of the SAT? So this is very applicable to you guys. All right, so if you score at the 73rd percentile, what does that mean? What does it mean? 73rd percentile. You're trying to interpret your results to see how you did versus everyone who took it. What's up, Nels? Yep, exactly. Okay, you did as well or better than. Okay, 73% of the students who took it. Okay, that's what it means for the 73rd percentile. That's where you fell. Okay, so you see it. You're at the 73rd. Not bad. 90 did very well. 50, average. Anything below that, not too good. But then you can take it again and again and again and again, as many times as you want. And there's your box whisker. And where do we want to go to? Okay, so we're going to go to the standard score. So the standard score, this is on page 107, okay, when we're looking at our formula. Okay, so the main focus of your standard score, it's the location of a standard deviation within a mean. Okay, so the location of your standard deviation within a mean. This is a way we can take all our data, no matter what it is, and go from our normal curve, our bell curve with our mean and standard deviation, and apply it to the same scale. Okay, and they're called z-values. So we're converting scores from original values to standard deviation units. So it goes to standard deviation. Remember, how many standard deviations above the mean do we show? 3. We show 3 above, 3 below. Your min and max usual values are where? 2 above and below. Okay? We always show 3. And we're going to see tables that are going to show up to 3.5. So here's your formula, which is z is x minus the mean all over the standard deviation. Okay? Now, in the book, it has z equals x minus mu all over lowercase sigma. Okay? That's fine. Or it could be z equals x minus x bar all over s. Because depending on if you have a population or a sample. Now, it doesn't matter. All right? And when we do our standard deviation, it matters because of the n versus the n minus 1. But with the z-score, it's the same formula. So that's why they only show you 1. Okay? If it was different, they'd show you different formulas. Okay? So in simple terms, the z-score tells us how many standard deviations. That's what it is, standard deviations. And remember what I already spoke about is the empirical rule. We were introduced to the 1, 2, 3 standard deviations and the p-value, the percentage between 1 and 2, 0 and 1, -1 and 1. Okay? Now we're going to find all those other values between. All right? And those are called z-scores. So we have a chemistry test given by Mr. Smith. Bob got an 87, Susie a 70, Jill got an 82. Class average was 84 with a standard deviation of 4.2. Compare their scores to the overall class population. So what I want to do here is I want to show the mean and 1, 2, 3. We're not going to draw the curve, okay, because I want to compare my x curve to my z curve. Okay, they're all the same. We're going to do this. 1, 2, 3. Okay, line them up exactly. So what we want to do is we want to find. So of course this is 84. So take a minute, find your standard deviations above, your 3 below on your x curve. Okay, so make sure you're able to get those numbers. Okay, you can write them nicer than I can. You can squeeze them in wherever you need to. All right, so you got your 3 standard deviations above, 3 below. And of course, you do the curve, whatever else. But we don't have enough room to do all the curves. Now, with a z curve, what's happening is the middle number is 0. Okay? And then what you're doing is you're going 1 standard deviation, 2 standard deviations, 3 standard deviations above. So those are +1, +2. Can you put your foot down, please? And then -1, -2, -3. Okay, because those are 3 standard deviations below. So no matter what your data is, what your x values are, you can always take them and change them to a z value. The mean of a z will always be 0. Yes. Okay? And then you have 1, 2, 3 standard deviations above, 1, 2, 3 standard deviations below. Now the key here with z-scores is you always round them 2 decimal places. Always, 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 a z-score goes 2 decimal places. Okay? So we take our information. What do we have? Chemistry test was given in Mr. Smith's class yesterday. Now, is this a population or a sample? Does it matter? No. Okay? So don't stress out about this, about, gee, is it a population, is it a sample? Because the formula is the same. If we're talking about standard deviation, yes, it matters. Okay? But for here, it's the same thing. So whether you use mu or x bar, it's fine with me. Okay? Some of the formulas, like I said, don't matter. Okay? The key thing that we know, these values here, okay, are your x values because we have the average. So we can say the mu is 84, standard deviation is 4.2. And the X values, so we have Bob, Susie, and Jill. So Bob's X value is 87. Susie's X value, Susie got a 70, and Jill got an 82. So to use the formula, you have your X minus mu all over the standard deviation. So what you're doing is your 87 falls 87 falls right about here, okay, on your X curve. So that means the corresponding Z value should fall in the same spot, which is right about here. Okay, so plug that in your calculator. Because it's Bob. Oh, yeah. Bob, Susie, and Jill. We got to find out where they're located. Okay. What's Bob? What's Bob? 0.71. Why 0.71? Always rounded 2 decimal places. How many people wrote that down? Mm-hmm. If you didn't write it down, how many people are going to remember it Tuesday? You won't. Okay, so you got to write things down. So the location, that makes sense, right? Because 0.71 is a little underneath 1. There it is. Susie's a 70, so my numbers are all together. Ooh, Susie, are you way down here? Okay, Susie's way down here. Okay, and Jill is an 82, so Jill's about here. Okay, so plug these values in. So Susie, 70 minus 84 over 4.2. And Jill is 82 minus 84 over 4.2. Yep, that's good for Susie. Well, good for you, not so much for Susie. And then make sure you guys are getting these values, negative 0.48. Okay, anybody have any problems or concerns or questions about getting those numbers? 84 is the mean. 4.2 is the standard deviation. Okay, just match it up to the formula above. Okay, now how many values are usual? How many are usual values? How many? No, how many? 2. Okay, and they are which ones? 87, 82. Why? Exactly, because they're within 2 standard deviations of the mean. Okay, are there any outliers? Who? Susie's an outlier. Okay, is it a good outlier or a bad one? She bad. She bad. You know? Maybe, you don't know. You know what I'm saying? Maybe she skipped. Well, in this case, you're talking about a test. You know what I mean? So, I mean, some people might want to fail. I don't know. I'm going to show my parents, But a good, in this case, because it's a test. So if I was up here, as an outlier up here, woo, I did, 98, 99. So that's good. But they're not all good. That's a good point, okay? Just because it's positive doesn't mean it's a good outlier, okay? We're going to be talking about weight, right? All right? If I'm 450 pounds, I'm like, oh, geez, you're an outlier, but not a good one necessarily. I'm not there yet. Close. Okay? So, oh, yeah, sure. Okay? So it can help you compare distributions, too. Okay? Kind of like when we were comparing the 2 distributions the other day. Some of you might not have gotten there yet. What was it, Long Beach and Los Angeles? Okay, so we can use it to compare as well. So here's, is this my last one? Oh, my goodness gracious. Oh, I got 2 of the same page. Okay. Is that us? You're the student. I don't think it is. Who knows? All right, so let's see what you can do here. Yeah, that's what I thought it was. John had 2 tests last Friday. Pre-calculus earned a grade of 87 with a class average 83, standard deviation of 1.9. Chemistry, he earned a grade of 79 with a class average of 77, standard deviation 3.5. For which class did he score better compared to his classmates? Okay, so what we're going to do is we're going to look at Z values so we can compare. Because he might be good for him. Okay, chemistry, he got a 79, not bad. And pre-calc, he got 87. So we have 2. We have our pre-calc, and we have our chemistry. Okay, so going to Z-scores in pre-calc, and usually it's easier to find the mean and standard deviation. So if you know the mean and standard deviation, okay, now the other value that they give you, the other piece of data, is your X value. So this is your 87. Okay, so if you get confused as to which is the mean, which is the standard deviation, do a process of elimination. Mean is the average. Identify what they are. No, you're just finding a Z value. That line was just to show you what a Z value is doing, what it's showing you. Yep, 2.11. And then in chem, you got a grade of 79, average of 77, standard deviation of 3.5. Point what? Very good. Okay. Is everyone able to get those values? 2 decimal places. If you go 3, you lose points. Okay. So what it is, it says, which class did he score better compared to his classmates? Okay. So based upon the mean and standard deviation, which one was he way at the top of his class? Which, like an outlier? Pre-calc. Okay. Because he was more than 2 standard deviations away from the mean. Okay. So some kids did poorly. Okay, or not as well. And then here for 0.57. If you were to show this in an X curve, which would have a wider spread? Remember, compared to Long Beach and Los Angeles, which would have a higher maximum, a lower minimum? This a range. We're talking about the range, not the grades necessarily. The range of values, which would have the higher range. Why? Standard deviation. Okay. All right. So all good.